Bahwan CyberTek for the opportunity to speak on this great topic. We're really excited to participate. So just to get started and kind of give you some perspective on where PTC is in this IoT journey, we really think about things from the digital thread and how we can connect, federate, and aggregate data. That's a key piece for us to be able to move in a contiguous fashion across systems, across data, across processes. So that allows us to move really from the design process through the implementation of a piece of equipment, through the sale of that equipment out into a customer, through the operations and maintenance process for that. So it's a really contiguous piece of information, again, that allows us to aggregate and eliminate a lot of duplicate processes, duplicate systems, and really go through a number of key areas there. What we're seeing in the market and what we're seeing from a lot of top analysts and researchers is the top use cases, the top trends that are very critical to helping in the factory, in an operational or asset-intensive session. So the first one is the Bain report from 2016, which talks about where they see IoT solutions in the factory or in an operational setting. So, if you look at some of those top three in particular, improving quality, helping to lower prices, and lower support costs. So again, driving that operational efficiency. Second would be to improve the productivity of the workforce. So if we give our customers a better view of information, if we give them more holistic access to data and to insight, they can help make a critical decision more effectively, have information at their fingertips to help them do that. And then the third is just increasing the reliability of operations. So that's, another key piece. So again, we see in plants and in operational settings a number of different types of data that's being aggregated, whether that's coming from SCADA, MES, manufacturing operations, ERP, supply chain, enterprise asset management, the whole key. Having that integrated and having that aggregated gives, from management to the operators and the maintainers of the equipment, better information. So when we went out as PTC and did that research, you'll see that we found many of those similar characteristics. So in the top right, the customer corporate strategy interviews, integration, asset monitoring, KPI management, and process optimization. Again, when we look at McKinsey's research on the similar piece, the factory impact is the largest impact for the industrial Internet of Things of any of the 9 settings that McKinsey looked at. So there's significant opportunity to help unleash additional economic opportunity and value. And then lastly, LNS Research, another great research firm focused on asset-intensive industries, went out and did a study, got about 250 responses, and you can see a number of key use cases that come in right around 25%: remote monitoring, energy efficiency, asset reliability, quality, and production visibility. So all things that asset operators are really striving to drive through. So we really look at how technology is transforming manufacturing and operations. So just to take on that digital thread and to take on the analyst research, we see organizations looking at digitizing their processes. So what does that mean? That means we're taking manual operations, whether it's paper-based work orders or routing sales orders or purchase orders for inventory, raw material goods. We're moving that into an electronic or digital process. We're seeing a lot more connected assets and the ability to censor and grab data from equipment. If you look at some of the information that's available, the cost point on doing condition monitoring is dropping rapidly. So being able to monitor things like vibration in a piece of equipment, temperature fluctuation, oil and fluid analysis, thermographic analysis, those types of trend data elements are coming down in their price per point monitoring, which makes it a more attractive setup for companies to monitor their equipment, gather that information. The ability to have interoperability, so being able to aggregate technology across different production areas, different functions within the plant, different plants that may come from various acquisitions. Having a broader stack allows you to more quickly aggregate that information, federate that information, and make decisions about that. And so cloud is obviously a part in that. And we're even seeing cloud now start to take hold in operational technology situations. Mobile has certainly been on the rise. And PTC has a fairly unique perspective in our augmented reality offering called ThingWorx Studio that allows us to superimpose augmented images or the digital twin of physical properties to help make better decisions and drive insight. And certainly big data is a key component of what we're seeing driving some of this transformation in the market. So that ability to collect and capture and store that data, and now to be able to make decisions off of that data using analytics to drive data into insight. So one of the sayings that we hear a lot is that data is the new oil and analytics is the new refinery. So if you think about it from that perspective, that's a pretty key piece of intel. We also know that this is a pretty large worldwide trend. So this is not an isolated hype cycle, we think. The three largest manufacturing economies in the world, the United States, Germany, and China, all have public-private initiatives around smart manufacturing, as we call it in the U.S., Industry 4.0 in Germany, and Made in China 2025. We also see India coming on board with a government private initiative along those lines. So major economies and major governments are recognizing the value and the potential that smart connected operations, manufacturing, digital transformation is providing. And if you look at McKinsey's stat here, 33% of the IoT economic value is going to come from factories, a full third. They're looking at 9 settings, so a third is coming from one of those 9 settings. So while not a majority of the activity, it is certainly the largest plurality of that activity coming out of the factory setting. So if we look at the traditional, conventional landscape for IT systems within a factory, it's based on the ISA Purdue 95 model, and that covers level 0 through level 5. So as we look at the stack at level 0, you're talking about the physical assets and materials on the factory floor, on the oil and gas rig, in the power utility. So we're looking at then at level 1, the sensors and instrumentation and the data that gets collected off of those pieces of equipment. And so that's, that can be very proprietary information. And we're seeing some moves with OPC UA and some other standards to open that up. As we move up the stack, we start to see things like equipment and process control. We then get into manufacturing operations management. So we're starting to move up the stack and get more information. But as we move up that stack, we're also seeing that integration is less broad. There's much more limited integration in a number of areas, and it's more customized. And then when we get to the top level, the governance and planning systems, things like ERP, supply chain management, those are really long decision cycles in terms of what information is being gleaned. They're typically enterprise solutions. We do see a number of larger enterprises engaged here, but some of the small and mid-market may or may not be involved at that L5 level. But again, it's a very custom set of integration, very deep and potentially costly set of tools to do that in the past. when we look at the opportunity with the IoT, oftentimes in the past we would talk about a rip and replace strategy. So we're going to take out system A and put in system B. Obviously that creates a lot of complexity. There's a lot of political battles that can occur within organizations over those technology changes, both from an operator's perspective as well as from an IT perspective. And so what we've done with ThingWorx within the PTC ecosystem is move away from that rip and replace discussion and use IoT systems to help wrap and extend those existing systems. Take that data, turn it into information, aggregate that information across systems, and use ThingWorx as a mashup or a single pane of glass view to help tie together those systems, bring together that information, give role-based applications across a variety of different screens and experiences. So you can see we have the traditional desktop or laptop in the office, we have tablet, we have mobile. Again, PTC with ThingWorx Studio can bring that into the augmented reality world and use that on things like Microsoft HoloLens or some of the other devices that are out there in the market for augmented reality purposes. And so again, it's really just a great opportunity to leverage this technology to grab information, to make better analytical decisions, and do so in a role-based fashion so people are not getting overwhelmed with data that doesn't help support their decision-making process. However, this is not all wonderful with no challenges. There certainly are challenges that arise when you're looking at an IoT or an IIoT kind of deployment. So some of those are, there's a variety of data sources, formats, and types. So you can be getting information, again, from ERP, from MES, from SCADA, from the machines themselves. So that's one piece that can be there. You'll also have a number of processes that are different. So if you think about a conglomerate manufacturer, they may do very different manufacturing jobs. They may have some that are much more simple processes to others that are a much more complicated process. And so based on their product portfolio, that diversity of manufacturing processes can help slow down any benefits that may be gained. The ability to then have interoperability, flexibility, and visibility has typically been a change. I think we saw years ago, we thought ERP was going to unlock more significant value than it did. And it certainly unlocked a tremendous amount of value, but I know many customers that I've worked with over the years have thought that ERP was going to give them just a much more insightful view and decision-making capability. But it can be difficult to get those systems combined. And if you think about the variety, the velocity, and the volume of information, just getting that all together can be a big challenge. Again, we talked about the changing of business products and processes. If we think about how manufacturing organizations are starting to look at changing their business model from selling a product to selling a product as a service. One of the common ones we've heard is going from selling jet engines to selling power by the hour. So as they look at changing their business model, that can also create a challenge because they may not want to transform their manufacturing process as well as their go-to-market process at the same time. Obviously, we all know that there can be significant demands on not only the operators in embarking on transformation, but certainly on the IT department. And particularly as some of the IT departments may struggle a bit with operational requirements, just putting additional demand on them can help challenge or delay the benefits gained from an IIoT strategy. And then lastly, we're certainly looking at things around risk of deployment, length of time, cost. Again, if you think about some of the big bang implementations done around some of these larger systems years gone by, those were very costly. They often ran well over time. They ran over budget. So it really can cause risk, and people may walk away from that risk. And as I go ahead and get ready to wrap up and turn it over here, I just want to talk about how we at PTC and how our partners like Bahwan CyberTek are helping to undertake that next generation of orchestration using ThingWorx. We've built an open and extensible platform to help address some of those interoperability risks, so it allows us to do that much more rapidly. It's going to give you the ability to connect systems, people, and assets at a much more rapid pace and a much more scalable pace. We have a number of customers that are taking a very agile methodology to deploying ThingWorx in their facilities. One in particular, Tech, is doing everything in 6-week sprints. So they're taking very consumable business problems, they're designing an agile methodology around this, and they're implementing fast, getting results, and moving on to the next problem. So they are not taking a big bang approach, spending months and months in design reviews and iteration, but moving very rapidly, connecting information, connecting systems, rapidly deploying those applications and moving them out. And then, again, with our technology, we can move that across a number of different real estates or operating systems or screen types. So it's a very open, robust architecture to cover that. And then some of the last things, again, is with ThingWorx, we really want to focus on giving you an open deployment strategy. So whether that's hosted, whether it's in a public or private cloud, whether it's fully on site, whether it's a hybrid model, the technology stack that ThingWorx brings to the table allows you to make the best determination of how you want to do that based on your piece. And that can be, you know, with a hybrid model, when we talk about predictive analytics, you may want to build the model in the cloud, but push the results of that model down to the edge so that you can run anomaly detection at the edge rather than passing up thousands and thousands of data points on a constant basis. So again, ThingWorx is going to help you address that in a very robust manner. And so with that, I'm going to turn the ball over to Stephanie to introduce our next speaker. Thank you.
All right, thanks. Thank you so much, Adam. So our next speaker will be Stanley Moses. He is the Director of Energy and Utilities at Bahwan CyberTek and responsible for Industrial Internet of Things. He takes care of solution creation, customer acquisition, and partner engagements. Stanley has architected analytic programs for Fortune 500 power generation, T&D facilities, and manufacturing companies that has resulted in significant asset operation effectiveness, and cost savings. Big thanks again to Bahwan CyberTek for partnering with us on this webcast. And now I'll give the stage over to Stanley. Thanks.
Thanks, Stephanie. Thank you all for joining this webinar. So it was very clear from Adam's presentation that asset analytics or IoT as a solution is fast accepted by people who are in the manufacturing, energy, and utility space. And the low-lying fruit is today at the predictive maintenance or remote service, those type of solutions. And obviously for all those, we need to have asset analytics as the main play. And that's the reason for our focus in asset analytics. Bahwan CyberTek has been doing asset analytics for the past 8-9 years. Now we have partnered with PTC and deploying the asset analytics on ThingWorx platforms. So a little bit of background, everybody in the call understands the importance of assets, the type of engagements which the operations crew, maintenance crew does on a day-to-day basis with respect to assets. So there's been a significant impact if a good amount of information could be provided to these decision makers, either operations or maintenance, at the right time. And interestingly, what we also see is there are data available. All it needs is integrating them together, contextualizing at the right format, and presenting it to the right decision makers. So with that background, our agenda for today's discussion will be to talk about who we are as Bahwan CyberTek, and then our IoT ecosystem, what we have created to address the space, talk about the various asset data types, what is existing in the production floor or in an energy space. Talk about a quick example of predictive maintenance, when it is approached, what is the respective benefits it creates. Talk about the various analytics values, the value created by an analytics type of projects, mention a couple of success stories related to it, and pass on to some discussions. Each one has a couple of just 1 or 2 slides, so this we'll make it really quick. So Bahwan CyberTek is a products and services companies. We are known for the innovation work, what we have done in the supply chain, logistics, oil and gas, banking, power, and telecom. We are the pioneers on the fourth-party logistics. We have been executing predictive analytics solutions for over a decade, and the type of large-scale implementations which we have done, engagements which we have done with government and banks are pretty significant. We are headquartered in Boston, Massachusetts. We also have other offices across the U.S. Now, how we are well positioned to address this industrial Internet of Things space. Anyone who understands Internet of Things very clearly will understand the complete flow of how data from sensors should be connected to an application and then effectively into a certain workflow process, connecting people in order to create a certain business values. So there are not just one piece which is sufficient for a successful IoT project, but a combination of sensors, IoT platforms, enterprise applications, or even point solutions which are needed to deliver that space. And based on our earlier relationship and our new partnership with company like PTC, as well as partnerships with sensor companies like HID and Cloudleaf, today we are well positioned to address this space. So either whatever it takes, integration, dashboard, contextualization, providing analytics on applications, or connecting that to workflows, we are very well positioned to do that. Now, to set the context for our today's discussions, typically when you are talking about an asset here, what we mean by an asset is nothing but an equipment which is tagged with a financial value which is written in the books of any manufacturing or an energy and utilities company. There are 4 types of data what is typically seen or predominantly recorded. The first is obviously data with respect to the operations of that particular asset. Say if you take a pump, you need to have a flow related to the pump or a pressure related to the pump. The second is equipment data, which is current voltage, that's the data about this particular asset, what is happening on the asset. It's good data about the condition of the asset. The third one is more transactional data, which is predominantly residing either in a CMMS or an EAM type of application, which contains history of maintenance, which contains details about its bill of materials, OEM, as well as any other specifications related to it. The last one, again, in real-time data, which is vibration. Historically, this was considered as the condition monitoring or the PDM of the manufacturing space. Now, this is also a good source of information, data about the functioning of any specific equipment or an asset. Now, what we are tending to do as part of the IoT initiative is to integrate all these data, because all these data are today residing in different systems. PLC SCADA has the process data, VFDs and certain controllers has the equipment data, enterprise application has data about the asset, and finally there are standalone vibration systems which are collecting vibration data. So how we can put all these together and set data analysis methods like pattern analysis, Markov chain, regression analysis, any specific outlier identification, applying all these logics in order to get certain findings which could be helpful for anyone in the organization. So it's not just the operations and maintenance. There could be information sought by the finance groups for certain approvals of purchase orders, or before they go ahead and approve an overall or a replace type of decisions. Even CXOs definitely need a lot of information about the data functionality in the last 1 year, so that they can set standards or set baselines for the next forthcoming year. So huge amount of data analysis, certain good analysis method is going to result in very good findings. So let's take an example of our today's maintenance situation. Most of the companies does calendar-based maintenance activities, either 15 days, once in 15 days, once in 6 months, or once in a year. The problem here is the equipment might fail at any time in between the scheduled timelines. There are companies which have moved forward to record run hours of the equipment. Here again, if the equipment or the asset is scheduled for maintenance on the 1000th hour, and if the equipment fails during the 800th hour, then it's a sudden downtime. The equipment has really taken a hit in terms of the deterioration. So a much better way of doing a maintenance activity is utilizing the equipment conditions. So considering the actual wear and tear of the asset, understanding or reading the actual condition of the equipment by either comparing the current data values with its history information or with an OEM recommendation. If you take an example of a pump, you could apply a pump curve, which is provided by the OEM, compare that with the current pump curves, understand the deviation. So this gives an indication not just by the condition of the equipment, but also indicates the efficiency of the pump. So there are other derived benefits when you're monitoring the conditions. But the best way of doing a maintenance activity is to understand the relationship between how the equipment is driving the respective process. Say if a certain feed water pump is pumping water, inside a boiler, what is this pressure ranges normally it is in, depending upon the head pressure values, creating a model, taking into account all the relevant parameters of the respective process will help us to ascertain the exact condition of the equipment. So, and related benefits like efficiency monitoring, or if you are talking about any domain-centric approach, it's heat rate monitoring with respect to power generation, or you are talking about power curves with respect to wind turbine generation. So all those things can be brought together. The interesting thing, as I said before, is data is available in PLC, SCADA, Historian, MES, or AM application. All it takes is how to effectively integrate that, apply the calculations which are needed in respective scenarios, and finally use those results into an application like asset management. And today there is an air gap between control systems or plant automation systems and enterprise asset management. But if we can effectively predict problems and indicate that into an asset management, it will be helpful for generating automatic work orders. So we are completely avoiding a situation where someone needs to identify a problem, work on the root cause of the problem, go to the stores for identifying spares, come back to fix the problem. So meanwhile, there's a significant downtime, production loss, as well as the efforts involved by the work crew in order to fix the problem. But in predictive maintenance scenario would significantly reduce all the adverse effects like the downtime or any production losses, or avoiding any production losses. So a couple of scenarios just to explain the feasibility or the approach of an asset analytics method. I'll explain the right side first, which is pretty straightforward from a deviation analysis standpoint. What extent my current set of parameters is deviating from my ideal set, or call it a golden badge, or certain companies also have call this as a baseline data values. Either we do that for a process set of values or for an equipment data set. It doesn't matter, but when you're able to map that data in that format, any deviation can be immediately identified. On the same lines, if you see the left side, intelligent alarm capture, assuming the square boxes are the alarm line or the high limit of a particular trend, the operations or maintenance crew is not much bothered, and also they don't have time to really look into situations what is happening on the trend when the trend is below its alarm limits. Whether is it a normal ramp, is it a sawtooth trend, or is it an erratic value fluctuations. So an IoT solution today can help companies analyze what's happening with respect to the trend, what is the reason for a certain format on the trend, and proactively indicate that there could be a potential problem either in the process or in the equipment related to it. So these are some of the methods which, as Bahwan said, CyberTek, we have successfully implemented and provided benefits to the customers. So this slide talks about the various categories when you are talking about analytics using IoT. I would request to read this slide from right to left, because immediately when you're looking to do any type of asset analytics, the value what you're trying to drive is the key, because that's going to be your that's going to be of the foremost importance, because of the decision making for doing a project. That's the one which is going to drive that. So either you're doing it for improving the effectiveness, utilization, or achieving any sustainability goals. So that has to be defined properly, and then the related analytics example of what are all the type of logics which has to be run on the data can be determined accordingly, and then gathering the respective data what is needed to execute those logics and create the output can all be put together has to be put together in order to successfully execute an analytics work. So some of the value proposition, this is a kind of a summarized slide of all the work what Bahwan CyberTek has successfully delivered so far, how the type of maintenance visits which it has reduced by around 4 to 5. 4 to 5 sounds to be a lesser number, but if you imagine the total number of maintenance crew involved in it, the number of visits everybody makes on a month-on-month basis, and when you calculate it for a complete year, the total avoidance of maintenance time is significantly reduced. And this parameter should go hand in hand with the reduction of downtime as well, because at the end of the day, you can't reduce your maintenance activities and allow an higher downtime. So we also monitor that closely on all our work, on all our success stories. So at least a 2% in decrease in downtime is what we have achieved in many of the projects. I talked about maintenance labor hours. That's the yearly cumulative value on the total maintenance hours, what we have delivered. Once we have a complete view about the status or the condition of the asset, the planning of the spares related to it can also be well planned. So you can either this can be helpful for optimizing the spares, considering all the relevant assets, or if it's a unique asset, you can also determine when is the likelihood that you need to replace a critical spare. Accordingly, you can plan all your procurement activities. And one of the intangible benefit what an asset analytics solution today provides is how it is increasing its economic life. This is pretty obvious because when you're running a particular equipment or an asset to failure, some of the components or almost most of the components takes a severe hit. So even if you replace one spare, there could be another spare which has taken a hit because of that particular run to failure situation. So when you're proactively doing maintenance on it, having that information about the condition of every component in the asset there is a significant increase in the economic value of all the equipment or the assets involved. So some of the case studies where Bahwan CyberTek has successfully delivered asset analytics solution. The first one is one of the large universities in the U.S., medical research universities. We are currently executing air handling unit analytics. The air handling units are a critical asset for the research community because they need to pump in 100% fresh air every time. They can't reuse any of the air, So today we gather data gather data from the air handling unit through OSIPI application, and the data involve data of the motor, the blowers, the temperature of the cooling coil, temperature of the heating coil, the valve positions, the valve conditions, and then we introduce logics similar to how a smart engineer or a smart operator would think about it. So if he is able to see a certain scenario, how he determines that there could be a potential for a failure, that's the similar type of logics which we introduce. We create models relating to various parameters like the heating coil condition, temperature against the valve condition, open level against the blower speed. So those are some of the scenarios which we incorporate in order to predict. So these air handling units most often are run in remote. Not many people attend to it, and today they have alarms coming out whenever there is a potential problem. The second example is the work what we have done at a major power generation company. So in this, what we have done is an analytics for their condenser equipment, condenser asset. Similar to the earlier example, we have incorporated all the data from their Aspen historian, which included data about the condenser equipment, specification of the equipment, as well as parameters of the condenser equipment like TTDs, inlet temperature, outlet temperature, pressure variations, and all sorts. So today, they're able to predict and tell what is the likelihood of any fouling on the condenser, what is the likelihood of certain pressure fluctuations because of which the complete output of the power generation is taking a hit. So all these scenarios help both the maintenance as well as the operation crews. And the last example which I wanted to mention today is some of the work what we have done with a large transportation company who have been using the Maximo application for quite some time, for the last 7-8 years, have huge amounts of data, maintenance information recorded about the bus and the rail which they manage. And today we run models and logics to determine what is the likelihood of a certain bus or a rail to fail, and when is it likely to come to the garage with what type of spare changes required. So those are the quick 3 examples which we wanted to share. There are a number of other examples. Today, as Bahwan CyberTek, we have created asset analytics models for all the large assets like motors, pumps, compressors, condensers, boilers, and chillers. So these are readily deployable applications as well. So the last slide for us to discuss today is the top 5 learnings, what we wanted to share based on the work we have done, what we have seen so far, how customers have benefited using the solution. The first, I mentioned this earlier too, outcome definition is the key. Asset analytics as such might not be a play, but what is the effect or what is the use of asset analytics is the key. Either it should be looked at an efficiency improvement program, sustainability improvement program, or operational efficiency. All those things has to be accordingly mapped. Data sufficiency, every company talks about it today. There are companies who are afraid of an IoT or an analytics word by just saying that we don't have sufficient data to do some such type of analysis. The surprising fact is Most of them either have that data already available in some forms or mean, just that all this data will be located in silos. And as well as there are companies who are just starting to record or historize data, but they will be looking to do an IoT or an analytics work. There are ways and means which can be applied in order to address specific scenarios like those. Third one is integration. Integration is the key. Today, PTC's Kepware OPC server helps in integrating almost all of the different applications, what is available in a manufacturing and an energy system floor. There are custom integration which happens with either MES applications or with even CNC machines. And so there are different techniques which can be applied to it. And the last one, when I'm talking about integration, is how effectively it can be pushed into the next level in the hierarchy, into the enterprise application. There should be a business case for pushing the data into an enterprise layer, but it's again on a case-to-case basis. So we have seen scenarios where a cement company wants to integrate all its equipment parameter, manufacturing parameters, and deploy it into or visualize it into an JD Edwards type of application. So we had done the integration, the data massaging, the data analysis, and finally presented the KPIs at the next layer. Scenario definition, this is the what is the type of techniques which has to be applied in order to generate the outcome, what is expected into, or what is the insight, what the customer is looking for. Companies like BCT and PTC, we have in-depth knowledge in choosing the type of mechanism, type of logic which has to run in order to create those type of outcomes. And ThingWorx has robust analytics built in order to deploy. So most of them are drag and drop. So there are scenarios where pilots getting executed in a matter of days or a week, and the complete deployment time for such a type of asset analytics program could be anywhere between a couple of weeks to a maximum of a month for a set of 3 to 5 assets. The last one is the system dependencies, to what extent the other system data has to be brought into, what is the type of ecosystem, what type of ecosystem, what is available, where exactly the ThingWorx is going to be deployed, and how effectively the system has to be delivered. Our system has to deliver its visualization either as a web portal or notifications. So all those things are key to the success of an asset analytics project. So that's it from my side.
All right, thank you so much, Stanley. Right now we're going to move to the Q&A portion. I will wait to get some questions in the chat functionality, so I'll just give everyone a minute and we'll take a look.